Hello world, this is my normal video from my camera, right? And I can turn it into this or this, and I am doing this all on my Mac. I first saw this style on AVTV's YouTube channel, and I can show it to you. So have a look at it.
How the hell do you make these damn visuals? And this is how. We do it with just the click of a button. Once more. Not bad, is it? Okay, no, it's not through this button. We do it.
Okay, so this is the way they use it, and they use it various other ways. They use a tool called Higgsfield AI, which looks insanely polished, which is very great. Prompt writing is much more easier there. uh, Now what I did myself is not very perfect, but it completely runs locally. It has no buying credits, no cloud processing, and I also wanted to understand how it runs underneath. And so let's see how it works. And I won't bore you with actual every line of code because most of it is written by AI, and we will, but we will understand how it is happening and all. So like this is, I will show you the input video that I had in the beginning, right? So this is the first input video that I used for testing, and this is just a 6-second long video. It is around 25 to 30 frames, frame rate FPS, uh, and like we can go here and see. So I can. So what happens is there is an input video, right? Each we all know that video is just images running very fast, and frame rate is like, if I say my video is 30 frames, it means there are 30 images in 1 second that are running, and that's pretty much it. So what we do in, we use Python, we use OpenCV, and we split each frame, and from like this video is .mov, uh, and we change it. We have each video frame, and we change it and make it to uh, NumPy array. So I have a collab example here. So I have test image, or we can upload our own image, and this is the image that I gave, and it made it like a pixel value array, 3D array. Each pixel value is a color, right? And we can see, like, imagine this is the complete image, and each value is just a color. So it makes it into array, and that array is passed to AI for magic happening. And when I began this for the first time, I used Stable Diffusion model, which is 20-step model, and like it takes 20 step. What does step mean? So you can see this is the example I got from the internet. So focus on the below image for now. So like this is where the AI starts, right? And then step 1, step 2, step 3, step 4, step 5, right? It took 5 steps to completely generate this image. Now generating this, now making taking the steps require time. So for example, when I say that Stable Diffusion used to require 20 steps, it used to require to do these things 20 times to get a like a pretty basic good looking output. But Flux, the model that we went ahead with, this 4 billion parameter model, it can do it in 3 to 4 steps. Actually it did it in 2 steps pretty well too. I will show the outputs that I made, but this is the model. It is very cool because it runs around like in 16 GB RAM too. It is just 4 billion parameters and fast. So first I tried with Stable Diffusion, but went on with Flux because it was much more easier, and the complete step happens in this similar way only. This is like the input image that we give, that is converted to noise. Then that noise is again converted by AI to data using its own AI processing things, and we do this for every frame of the video, and then each frame is again rebuilt uh, into this. But like the like the way I speed up the things is, the input video was around 30 frames, right? And in the beginning I used to build all 30 frames. So if you see the cartoons and all the things we see in olden times, they were just drawings, right, drawn by human, and then the images are fast forwarded and we see it as a cartoon video. So they never had 30 frames because it is a lot of hard work to draw 30 images for 1 second video. So they used 15 or 12. Like 12 was one of the standards most of the Japanese cartoon shows that we see. And I also kind of add a param to the script to take FPS rate, and I went on with 15 and then I downgraded to 12 FPS, uh, and it gave a pretty good result too. So there were other things, other optimizations that I tried. So first one was the we already saw that we lowered the FPS. Every 20 frames we added cooldown so that Mac doesn't get heated up. Fewer steps, like Stable Diffusion was taking 20 steps, and then we came down to 2. Actually, the final one I made was with 2 steps, and that's one of the. And then chunk model was for Stable Diffusion, not for the Flux. Stable Diffusion is a smaller model, like it was smaller as compared to Flux, and Stable Diffusion has a lot of things made around it. So I added some weights, and the weights were only getting included to RAM when the model is running and when it needs that specific weight. That was some optimizations that we did to avoid memory overload. And that's it. And let's just jump out to the output that we made. So this was like the first output that was made by Stable Diffusion, which was not exactly right. It didn't give, in the beginning it was unable to get the input frames for some reason, and that's why this started to happen. And then it is the same thing. It was not getting the input frame rate and it was randomly generating. This was the first time it at least got, it started to get the frames correctly and building it. But as we can see, the Stable Diffusion was not very good at like making the next frame similar to the first one, which had, and this was just blank for some reason. Then I tried to switch that to sketch so it gets a little bit better, and then we can see it just went on, like it was making this flashy images instead of making the complete thing. Or at least the most important thing in this video making was that when it generates the next frame, it somehow like well connect to the previous frame, so that it is like, it feels like a complete connected video. But it was not happening with Stable Diffusion. So I went on with Flux, and this was the first output that Flux generated of few frames. And I tried 1 second, 2 second, 3 second, and moved on. Like this is the 7-second complete video that it generated. It was very cool. It was pretty much better than all the other all the previous things we tried. And this was like colorful, vibrant, anime style prompt. Now my prompt are not the best one. I just have 3 to 4 keywords, and I tried this with that prompting. If someone wants to try, I can put all of this in GitHub. It is very messed up completely currently because I have multiple files doing multiple things, and that's it. I wrote this Python script like couple of Sundays ago, and finally yesterday I recorded this video. And I know it is not the perfect and the fastest way to generate this kind of videos. Like if you run this model on NVIDIA high-end GPUs, it will be way much faster. Like just to give you an idea how much time it took on Mac, I can flash the screenshots I took of the output, and like you can see the fastest frame that was generated was in 1 minute 40 seconds, which is like 100 seconds for one frame. And if we say that we do this at 12 fps, then to generate a video of 1 second would require 1200 seconds, which is like 20 minutes. So 1 second video will be generated in 20 minutes on Mac. And I'm not even counting the energy battery drain that it would have required, because like I plugged my Mac the whole time. And so I can say that this video is sponsored, and it is sponsored by my charger, because without it this video would have been not possible. But honestly, I enjoyed doing this because it gave me a proper insight of how everything like this works. And thank you for watching, and see you in the next.